Hello, students. Myself, Mrs. Mansi Agarwal, Assistant Professor, Department of CSE AIML, ABES EC Gazeba. Today, we will be discussing our next topic of data structures, that is selection sort. Selection sort is a sorting algorithm that repeatedly finds the minimum element from the unsorted part of the array and places it at its appropriate position, sorting the array one element at a time. So in order to understand how the selection sort works, let us take an example in which we have 5 elements. Suppose these are the 5 elements, 15, 25, 12, 27, and 11. Now, in order to sort these elements, the basic idea is, as the name suggests, selection sort. What we have to do is, we have to select the minimum element and place it at its appropriate position. Again, in the unsorted array, again we have to select the minimum element and we have to place it at its appropriate position. Let us try to understand this. Suppose we have these 5 elements, 15, 25, 12, 27, and 11. So in the first iteration, we have to find out the minimum element in the array. So what is the minimum element? 11. And we have to place it at the beginning of the unsorted array. And at the starting, this entire array is unsorted array, right? So what we are going to do is, we have to place this the beginning of the unsorted array. That is, we have to swap 15. We have to swap 15 and 11 such that the array will become 11. The rest of the elements will be same, 25, 12, 27, and 15. Now, what is the basic idea behind finding out the minimum element in the array? First of all, we will take a variable. Suppose we have taken min, and we will consider that the first element of this unsorted array, is minimum, right? So I'm just simply storing the index of this element in minimum. So because we are doing algorithm, so the first index of the array will be 1. So let us consider minimum to be 1. Now we will repeatedly check minimum with the rest of the elements of the array. We will repeatedly compare a minimum with the rest of the elements of the array. So at the first time, we will compare a minimum, that is 15, a of minimum, that is 15, with the rest of the elements. So the first element that we will consider is A2, and this is 25. Now, because A2 is greater than A minimum, so nothing will be changed. Simply, we will move on to the next element, that is A3. We will now move on to the next element, that is A3. And the value of A3 is 12. So now we will compare A3 with A minimum. Here, the value of A3 is 12 and it is less than A minimum. So the minimum index will change to 3, right? So now A minimum will become 12. Again, we have to compare this A minimum with the next element. And what will be the next element? The next element will be A4. And the value of A4 is 27. 27. Now again, A minimum is less than A4, so nothing will be changed. We will simply move on to the next element, that is A5. What is the value of A5? What is the value of A5? This is 11. Right. Again, A minimum will be compared with A5. Now, again, A minimum is greater than A5. So we have got another element in the array which is less than A minimum. So again, what we have to do? We have to simply change the index stored in minimum to this new lesser value. That is 5. Right? All the elements have been finished. So after this whole pass, minimum will have index 5, which is the index of the smallest element of the unsorted array. Now what we have to do is we have to simply swap the first element that was considered to be minimum with this actual minimum element of the array, such that the state of the array will be 11, 25, 12, 27, and 15. So this is all about the first iteration. After first iteration, this much array, that is one block of the array, is sorted and the rest of the array is still unsorted, right? So again, for the next iteration, what we have to do is, again for the next iteration, iteration number 2, again we will consider the first element of the unsorted part as the minimum. So minimum will have its index, that is 25. 25's index is 2. So minimum will have 2. And this 2 will be compared with the rest of the elements so as to find out the minimum element in the unsorted part, right? So as you can see that minimum, the A minimum will be compared with A3, A4, A3, A4, and A5. So in this case, 12 is minimum. So after this pass, minimum will have the index of 12, that is 3. And then this 12 will be swapped with 25. This 12 will be swapped with 25. So after this pass, after this iteration, the array will have the values 11, 12, 25, 27, and 50. Right. In the similar way, in the next iteration, iteration number 3, now as you can see that these two elements are now part of the sorted array and the rest of the elements are unsorted array. So for the next iteration, the minimum value that we will get is 15, and this will be now swapped with the beginning of the unsorted array. So 25 and 15 will be swapped, and in the third iteration, the array will have values 11, 12, 15, 27, and 25. And after this, these three elements are sorted and the rest of the elements are unsorted. Again, we will find out the minimum and we will swap it with the beginning of the unsorted part. So, in iteration number 4, as we can see that now the values will be 11, 12, 15, 20, 25, and 27. So we can see that if there were 5 elements in the array, then in 4 iterations, the array is sorted. So we can say that for n elements, we will need n minus 1 iterations to sort this array with the help of selections. Now let us try to make the algorithm for what we have just seen. We can see that for the first iteration, minimum, we have taken a variable minimum that was storing the first index, that was 1. And then it was compared with the rest of the elements. So we can say that for j, taking up the values from 2 to the last value, that is n, from 2 to the last value, that is n, what we have done? We have compared the minimum value with aj, right? We have compared it with a2, a3, a4, and a5. So if at any point of time this aj that is the rest of the elements in the unsorted part, is less than A of minimum, is less than A of minimum, then we have changed the index stored in minimum and we have stored J in this minimum. So minimum will get a value J. That's it. And when we came out of this loop, of this for loop, we have simply swapped. We have swapped A of 1. That means the beginning of the unsorted array with A of minimum. We have swapped these two elements of the array. That is what we have done. Right. So this is only for the first iteration. This is only for the first iteration. As you can see that we have repeatedly selected a minimum value and then we have finded out the actual minimum value in the unsorted array. We can say that this minimum has taken a value from 1, 2, 3 and 4. Right. So we can put this code inside another loop where we can take another variable, suppose I, which is taking up the values from 1 to n minus 1. And every time we are storing this I in minimum. So this minimum is actually taking I. As you can see here, the minimum started with 1. Then here the minimum started with 2. In the next iteration, the minimum started with 3 and so on. Right. So the minimum is equals to I. And then whichever element we are considering as minimum at the beginning of the iteration, it will be compared with all the next elements, starting with the just adjacent element, right? So that means this J is starting from I plus 1, isn't it? This is starting from I plus 1. And the rest of the code will be same. Only there is one difference, that the swapping will be done with the first element of every unsorted part, So the unsorted part in every iteration is starting from I, right? So what we have to do is we have to swap AI with A minimum. This is the algorithm. So let us just try to see this algorithm. Suppose selection sort is the name of the function. There are two parameters, A, that is the unsorted array, and N, that is the number of elements of the array. So we have to start the first loop that will tell us the number of iterations. I will start from 1 to n minus 1, 1 to n minus 1. Minimum will take up the value of I every time. And then J will start from the next element because we have to find out the minimum in the unsorted part. So J will be from I plus 1 to n. And every time if we will get AJ, which is having a lesser value than A minimum, then minimum will change to the index of that value. So minimum will be equal to J. And when we will come out of this for loop, we have to swap the AI with A minimum. Let us now quickly implement the algorithm for selection sort. So for this, I have created a new file. First of all, let us include the header file, standard input output, in order to use the inbuilt functions. The user-defined function to perform the selection sort can be named as selection sort. And as discussed earlier, it will have two parameters. One is array and another one is the length of the array, that is the number of elements, n. So for doing the selection sort, we need some variables, I and j for implementing the loops, min for storing the index of the minimum element, and we can take a temporary variable for swapping the elements. Now, the outer loop that was giving us the number of iterations will run for n minus 1 times. So here, as I is starting with 0, so it will go till n minus 2. That is the second last element, right? And we have to increment the value of I. Inside this loop, we have to put this beginning index of I into minimum, and then we have to repeatedly compare this A minimum with the rest of the elements. So the value of J will be I plus 1. We'll start from I plus 1 and it will go till the last element, that is n minus 1. And we have to increment the value of J. Inside the inner loop, we have to compare A of J, that is array of J, with array of minimum. And anywhere, if the value of jth index, the value stored at jth index is less than that of the value stored at the minimum index, then we have to change the minimum and we have to set it to j. That's it. When we'll come out of this inner for loop, we have to swap the values. So we can simply write temp is equals to a of I. We have to swap ai and a minimum. So temp is equals to ai, and then ai is equals to temp. So the name of the array that we have taken is ARR. ARR I is equals to ARR min, and ARR min is equals to temp. That's it. These are the 3 steps for swapping the values. And in the main function, in the void main function, I am taking an array A and I'm initializing it with some values. Suppose the values are 25, 15, 12, 27, and 11. Suppose these are the values. Then the number of elements can be calculated with the help of size of operator. Size of ARR divided by size of A. Here we have taken A. Size of A divided by size of int, because the array is of integer type. And then we have to call the inbuilt function with the name selection sort, and we have to pass 2 parameters. One is the array storing the elements, and the another one is the length of the array, that is n. And after the user defined function will complete its execution, we have to display the sorted elements. So we can write the sorted elements are, and then we know that in order to display the elements of an array, we have to write a loop. And for that, I have taken I is equal to 0, less than n, I plus plus. And I can here call the printf function with %d as format specifier. And the value that we have to display is a of I. That's it. I think this code should work. And yes, as you can see, the values of the array are sorted as we have got 11, 12, 15, 25, and 27 as the output. Now, see how the complexity of this code can be derived. So, in order to check for the complexity, let us draw the array that we were taking, and If we have to discuss the worst case complexity, then let us consider that all the elements are in the opposite, in just opposite order as we want. So let us suppose the elements of the array are stored in descending order. So let the values be 27, then 25, then we have 15, then we can have 12, and then we can have 11. Now in this case, for the first iteration, we know that the variable min will store 1, that is, it will point to the first index, and then it will be compared with all the elements of the array, right? With rest all the elements of the array. So if there are n elements in the array, then in the first iteration, this minimum will be compared with n minus 1 elements. I think it is clear to all of you. And then after first iteration, when here we will get 11 and here we will get 27, in the next iteration, minimum will store the index 2 and then it will be compared with the rest of the elements, right? So in the second iteration, the number of comparisons will be n minus 2 and so on. In the last iteration, there will be only one comparison. The second last element will be compared with the last element. So if we reverse this expression, we'll get 1 plus 2 up to n minus 2 plus n minus 1. And we know that this expression can be written as n into n minus 1 by 2, which gives us n square by 2 minus n by 2. This is nothing but a function of n with the highest order of n square. So this can be represented as big O of n square, right? So this is the worst case complexity. This is the worst case complexity of the selection sort algorithm. Now, let us now consider the best case complexity. If you remember, the best case complexity in the insertion sort was ON, because for every element, there was only one comparison that we had to make with the previous element. As soon as we saw that the previous element was up to the mark, there was no need to further go on to the previous elements, right? But what will happen in this case? Let's see. Let's take an example in which the array which I'm taking is, suppose it is already sorted. So the values are same, but they are sorted 11, 12, 15, 25, and 27. Now in this case, for the first iteration, the value of minimum will be 1. That means the minimum will be pointing to the first index, will be storing the first index. Now, even though this value 11 is minimum, but still we have to compare it with all the elements, of the array other than 11, right? So in this case, the number of comparisons will be n minus 1. Similarly, next time when minimum will store 2, that means this. Still, in order to check whether this is minimum or not, we have to compare it with the rest of the elements. So in this case also, the number of comparisons will be n minus 2 and so on. In the last iteration, the number of comparisons will be 1. So again, if we will reverse this, we will get 1 plus 2 up to n minus 1. This can be represented as n minus 1 by 2, and which is nothing but big O of n square. Now, so as you can see that the time complexity for average case is O(n) square, for best case is also O(n) square, and for worst case is also O(n) square. Now, let us also discuss the space complexity of the selection sort algorithm. As you can see that to implement this sorting technique, we have taken a few other variables other than the array and the length of the index that were given to the code, to the algorithm, we have taken I and j to execute the loops for the iteration and to check the minimum number. Then we have also taken a minimum that is used to store the address, the index of the minimum element. And in order to swap AI and a minimum, we have also taken a variable temp that I have discussed during the implementation. So these are the three variables that we have taken to implement the selection sort, but none of them is dependent upon the length of the array n. And so the complexity, the space complexity of this algorithm will become O1, which is constant. These are the references we have taken for making this video. The first one is Tenenbaum's data structures using C and C++. The next one is Fundamental of Data Structures by Galgotia Publications. The next is Data Structures by Shams. And the last one is Dhareja's data structure using C. Thank you.